Hey guys, this is Sakshi and I welcome you all to my edutech platform, Way to Learn. So, let us solve some more problems like 10 sets of PYQs from GATE exam, and these PYQs are mainly for mathematical physics. I have already solved like 20 questions, 1 to 10 and then 10 to 20. So, this is the other set, the third set. So, we will be solving around 100 PYQs. So, there will be around 10 PYQs in each video. So if you haven't subscribed my channel, please subscribe, hit the bell so that you get the notifications of my videos, and also share these videos with your friends and help them out solve together. So let us solve these next 10 PYQs from GATE exam. So let us go for 21. Question number 21, which is from GATE 2005. And here the eigenvalues of the matrix are asked. So if you see, this is a 4 by 4 matrix, and it would be difficult if you consider the characteristic equation and solve this problem. So here you're going to use the property of matrices, where trace of matrix A, consider this matrix as A, so trace of matrix A will be sum of eigenvalues, and also it will be equal to sum of diagonal elements. So if you add the diagonal elements, you're going to get 0 plus 0 plus 0, which is 0. So trace of this matrix will be 0. So now you're going to use the option. So if you see option A, and when you add these options represent the eigenvalues obviously. So when you add these eigenvalues, you have to get a sum to be 0. So if you add all the options, only option A satisfies this property. That is minus 2, minus 1, plus 1, plus 2. When you add this, you get 0. So therefore option A is the answer. So let us see the 22nd question, which is from GATE 2006. So here if you see the question, a linear transformation T defined as T into a column matrix is equal to a column matrix. Transform a vector X from 3D real space to 2D real space. So this transformation vector transfers the vector X from 3D to 2D real space. So we have to find what is this transformation vector which does this transformation 3D to 2D. Okay, so if you substitute any one of the option in this place, you're going to get the answer. So if you're going to substitute, like let me substitute option A, which is let T be 1 1 0 0 1 minus 1. So this is my transformation matrix. I'm going to use it from the option. So according to the question, when T acts on x1, x2, x3, you get x1 plus x2, x2 minus x3. This is not from the question. You can see directly over here, when T acts on this, you get x1 plus x2 plus 0. Therefore, the answer will be x1 plus x2. Then 0 plus x2 minus x3. Hence, the transformation vector will be option A. You can also choose other options too, like B, C, and D. So if you choose them, you're not going to get the same answer as given in the question. Therefore, option A will be the correct answer over here. So let us see the next question, which is from vector. And this is an easy question. You just have to do some calculation over here. So if you see here, let us consider this function to be, this particular f to be r vector by r cube. So if you see, this is the surface integral f vector dot ds vector. You can use the Gauss divergence theorem. This is over the surface and this will be over the volume, where you can use the Gauss divergence theorem del dot f into dv. So by using GD theorem, we are going to solve this particular question. So now you have to find del dot f. So once you find that, it's easy. You can directly substitute in the integral and you're going to get the answer. So now, what is del dot f here? First, let us see f is r vector by r cube. So here r vector will be xi plus yj plus zk, and modulus of r vector, that is magnitude, which will be root over x square plus y square plus z square. But in our denominator we have r cube. So therefore we can say that r cube will be x square plus y square plus z square the whole power 3 by 2. So this will be the magnitude with the power of 3. So now let us see how to solve this. So we are going to find del f. Okay, so when you do this, you are going to get dou by dou x dot x divided by x square plus y square plus z square the whole power 3 by 2 plus dou by dou y divided by x square plus y square plus z square the whole power 3 by 2 plus dou by dou z divided by x square plus y square plus z square the whole power 3 by 2. So I'm going to solve this particular differentiation. So I'm going to differentiate this particular term. It is your job to continue this differentiation for dou by dou y and dou by dou z and solve this problem. So I'm going to give you the answer, what will be the answer, but I'll just show you how to differentiate this particular thing. So now for dou by dou x, I'm going to use UV method. I'm going to bring the denominator to the numerator with the power minus 3 by 2. So I can use the UV method now. So when I use the UV method over here, first I'm going to just write this. I'm going to differentiate u prime, this is u and this is v. So u will be 1, that is u prime will be 1 plus v prime u. So u is as it is. So now when I differentiate this p prime u, I'm going to get minus 3 by 2 into 2x the whole divided by x square plus y square plus z square the whole power 5 by 2. So this x square plus y square plus z square, this 2x is from this x square. Okay. So when you like simplify this, I'm going to cancel this. And then when I simplify the denominator for these two terms, I'm going to get x square plus y square plus z square minus 3x square the whole divided by x square plus y square plus z square the whole power 5 by 2. So this particular differentiation gives me this thing. So similarly, when you try this for dou by dou y, you're going to get instead of this 3x square, you're going to get 3y square. And for z, you're going to get 3z square. So when you add all these terms, finally you're going to get del dot f to be 0. Therefore, integral f vector dot ds vector will be 0. And hence the option should be A. So just solve for the second differentiation and the third differentiation and add those. Check if you get 0 or not. Let us see the next 24th problem. Okay, this is from complex analysis and this is also from GATE 2006. The value of this particular integral. So the first thing what we do is, over here is draw the circle. So here the C is a circle. Okay, the C is a circle defined by Z is equal to 3. Therefore, for Z is equal to 3, I can say that the origin is 0, 0 and the radius will be 3. So sorry, this is something, okay. Now if you see, Z is equal to 3, how do I know that my origin is like 0 and my radius is 3? You can use this particular formula, Z minus center is equal to radius. Z minus center is equal to radius. So this will be one of the formula in order to find the center and the radius of the particular contour. So here my radius is 3, and if you see, there is nothing over here. There is nothing, no number is given along with Z. So therefore I assume it to be 0, and that would be my center. Okay, so now a part 2Z. Okay, this is the first step. You had drawn the circle. Second step is to put the denominator to 0. So when you do this, you're going to get minus 1. Z is equal to minus 1 is your pole. So this is the pole of order 4. So if you see, the order is 4. 4. Therefore, Z is equal to minus 1 is the pole of order 4. Therefore, now we are going to find the residue, wherein you're going to use the formula 1 by 3 factorial d cube by dz cube z plus 1 the whole power 4 e power 2z divided by z plus 1 the whole power 4 z is equal to minus 1. So when I differentiate this, e power 2z thrice. So when you differentiate e power 2z for once, you're going to get 2 e power 2z. So when you do this, do the same process 3 times, you're going to get 2 into 2 into 2. That is 8 e power 2z at z is equal to minus 1. So when I perform this, 1 by 3, sorry, 1 by 3 into 2 into 8 into e power minus 2. So my residue will be 4 by 3 e power minus 2. So this will be my residue. Now, after using this residue, I'm going to use the Cauchy residue theorem and find the integral value. So which will be 2 pi I into residue 4 by 3 e power minus 2, which is 8 pi I e power minus 2 by 3. So this will be option A. Therefore, option A is right answer for this particular question. I hope you get this question easily. So practice such type of question so that you can, like, you won't forget how to do step by step the process of solving this particular question from complex analysis. Okay, so let us see the next fifth question. The kth Fourier component of f of x is equal to del x is. So here if you see, the kth Fourier component of f of x is equal to del x is what? So this is very simple. The Fourier transform of is basically written as 1 by root 2 pi integral e power ikx minus e power ikx f of x dx. So here f of x will be delta x. So 1 by root 2 pi minus infinity to plus infinity e power minus ikx is in delta of x dx. So using the property of delta of x, we get this integral to be 1. So the Fourier component of this is the kth term, right? So the Fourier component of f of x, that is the delta function, will be 1 by root 2 pi. Okay, so this one is very easy. So let us see the next question. This is again from matrix. One of the eigenvalues of matrix is given. The other two eigenvalues are what? So if you see, one of the eigenvalues is 5. Okay, now we are going to use the properties of the matrix where trace, let me assume this to be A. So trace of A should be sum of the eigenvalues, and here the trace is 5. And okay, trace is 5 and your eigenvalue, one of the eigenvalue is 5. We have to find lambda 2 and lambda 3. So if you see the option A satisfies, option C satisfies, right? When you add 5 plus 0, you're going to get 5. And when you add 5 plus 1 minus 1, you're going to get 5. So therefore, this property does not help us over here. So we are going to go for the second property of matrices, wherein uh, the determinant of A will be equal to lambda 1 into lambda 2 into lambda 3. Okay, so first let us find the determinant here. So that of A will be what? 2 minus 0 minus 3, 3 minus 0 plus 0. So when we do this, this will be minus 5. Therefore, delta of A will be minus 5, and this should be equal to lambda 1 into lambda 2 into lambda 3. So we have only two options with us, A and C. So when you multiply 5 into 0, the answer will be 0. Hence, this option is not the answer. So now if you see option C, 5 into 1 into minus 1. Obviously, it satisfies this property. Therefore, option C is the correct option. Now, there is a continuation of this problem which goes on for the second, like 27th problem. So here, if you see the problem, the normalized eigenvector corresponding to the eigenvalue phi is. So let me, I have to find the eigenvector for the eigenvalue phi. Lambda is equal to phi. Let me write the matrix over here. So 230, 320, 001. So this is our matrix, and we have to find the eigenvalue. So we can use A minus lambda I into x is equal to 0. This characteristic equation. Okay, so when I'm going to use this, so I'll be getting 2 minus lambda 3 0 3, 2 minus lambda 0 0 0 1 minus lambda into x y z equal to 0. So instead of lambda, I'm going to use phi. Here lambda will be equal to phi. So now our matrices will be like 2 minus 5 will be minus 3 3 0 3 minus 3 0 0 0 minus 4 into xyz is equal to 0. Therefore, minus 3x, when we solve this, we get minus 3x plus 3y plus 0 is equal to 0. 3x minus 3y plus 0 is equal to 0. And minus 4z is equal to 0. So from this last third equation, we can say that z is equal to 0. And from this these two equation, I can say that 3x is equal to 3y. Therefore, x will be equal to y. Now, we have to find the normalized eigenvector. So, normalized eigenvector will be basically like x staggered x. So, I'm going to write the eigenvector here as kk0. I don't know the value of k, so I'm just using kk0. So, now when we normalize this, we are going to get 1 by, okay, easy method is just you have to get the normalized, right? Okay, now we need the normalized eigenvector over here, which, okay, let us assume this normalized eigenvector as x. Okay, this is a normalized eigenvector. So normalized eigenvector will mean nothing but the component square of these components into k, k and 0. So when we do so, we are going to get 1 by root 2 k into k, k 0. So now we can assume a value for k. So I'm going to assume the value for k to be 1. So when I put that, I get 110. So therefore, if you see, the normalized eigenvalue will be, eigenvector will be option D, 110. 1 by root 2, 110. So this is a simple question again, and that was a continuation of the last problem. So you can easily gain 2 marks in this question. So let us see the next question, 28th question, GATE 2007 from year 2007. So this is from the differential equation, and we hadn't solved any differential equation till now. So let's solve this now. X dy by dx plus y is equal to x power 4. So dy by dx plus y by x is equal to x cube. I am dividing this x through my equation. So I'm going to get this particular value. And this will be the first order differential equation. You have to check the order first. So this is the first order differential equation. So we are going to use the integral factor. Okay. So here okay, let me write this. This is of the form dy by dx plus p of x is equal to q of x. So my p of x here is 1 by x and q of x is x cube. Now the integral factor is nothing but e power integral p dx. So integral factor over here will be e power integral 1 by x dx, which is nothing but e power ln x. So e power ln x will give me x. Okay, e and ln will cancel each other. Therefore, we get integral factor to be x. Okay, so the solution for such kind of equation is nothing but y into integral factor is equal to integral over integral factor into q dx plus c. So now let us solve this. When we do this, integral factor is x, right? Y into x is equal to x into our q is nothing but x cube dx plus c. So the answer will be yx is equal to x power 4. So on integrating this x power 4, we get x power 5 by 5. So x power 5 by 5 plus c. So I can divide this x throughout this equation. So else we can just have this x here itself. Okay, now we have to find this integration constant. So we have the boundary condition that y is equal to 1 at x is equal to 1. So y is equal to 1 at x is equal to 1. Therefore, 1 into 1 is equal to 1 by 5 plus c. So 1 minus 1 by 5 is equal to c. So 5 minus 1 will be 4 by 5 is equal to c. So therefore, you can write this equation, this solution as yx is equal to x power 5 by 5 plus 4 by 5. Now I can bring this x over here. So y is equal to x power 4 by 5 plus 4 by 5x. So if you see, the option will be, so option D satisfied, x power 4 by 5 plus 4 by 5x. So this is also a easy question. Just you have to remember what kind of differential equation is this and what kind of solution we need to do. If you do not remember, please try to revise these differential equation, their solution, and try to work out like around 10 problems in each type so that you'll have a command on it. So let us see the 29th question, which is from Laplace transform. We have to find the inverse Laplace transform for this particular function. So this is very easy. The function is nothing but s plus 1 divided by s square minus 4. So I'm going to separate this denominator for the numerator. Now if you see, this is of the form s divided by s square minus a square, right? And here, now if you see, there is like, you can't include s over here. It will not satisfy this particular equation. It will become more tedious process to solve. So we can use, in other form, we can use multiplying and dividing by 2. So I'm going to multiply and divide by 2 over here. So when I do that, I get s square minus 2 square plus 1 by 2 into 2 divided by s square minus 2 square. So if you see, this is of the form cos hx and there is cos h2x, cos h ax. Okay, and this is of the form sin h ax. So the inverse Laplace transform of this function will be cos h2x plus half into sin h2x. So very simple, option D. So let us see the last problem of today, which is from 2007, and year 2007 is also from differential equation, special function, Legendre differential equation. If you see, in Legendre differential equation we have n plus 1, but here instead of n we have 3 by 2. It's just to like deviate you from the problem. Okay, if you read the question, very simple question, you don't have to work out at all. The points where the series solution of this Legendre differential equation, they have given what kind of differential equation is this, so you don't have to identify two. So this is a Legendre differential equation will diverge. So we have to find the points where the Legendre differential equation will diverge. So if you remember the orthonormal property of Legendre differential equation, you can easily identify the singular points. So singular points, or okay, just remember the singular points or uh, point where function diverges. Okay, these are similar to like, okay, if you get any question with these names, that is singular points, points where the function diverge, all such, you have to remember the orthonormal property of the Legendre differential equation, and in that orthonormal property you just have to remember the limits of the integral. So you don't have to remember the whole property. It is enough if you remember the limits of that particular equation. So in the Legendre differential, it is just a trick in order to remember. For you can use this trick for all your special functions, Bessel, Laguerre, and Hermite too. So here, if you see in the orthonormal property, the polynomial will be the integral will be minus 1 to plus 1 pn of x pm of x dx delta mn. Okay, delta mn. So it will be somewhat like this. So minus 1 to plus 1 will be the integral, so this points are the point where our function will diverge, or these points are also called as singular points. So therefore when we have Legendre differential equation and we have to find the point where the function diverges, or a point all the singular points of the particular function, you have to use the orthonormal property and use the limits given in the integral. Those are those points, which is option C. So just forget about this n term over here. It is just to deviate you from the problem. Okay, so thank you. I hope you like all those videos, and just practice these 30 problems till now for GATE mathematical physics. I hope you just work out along with me. So if you do so, it will be very much helpful for you. And if you know some kind of problems, just pause the video and work out, like you work out first and then check the answer later. So I'll be posting more videos on classical mechanics, and then I'll be starting a new subject which is quantum mechanics. So I'll be posting videos on that too. So subscribe my channel and hit the notification bell. So, and also do not forget to share my videos. So thank you. See you later with my more videos. So thank you.